Okay. So today we start one of the important topic, that is nothing but the dynamic memory allocation, and that is one of the important topic, you can say, in C and as well as the C++. In C++, actually we are dynamically allocating the memory by using one extra, you can say, the inbuilt functions, but in C that all are done by using some inbuilt function. We will see that. So the thing is that in that particular case, so what do you mean by dynamic memory allocation? So before that, it will always been better that we will understood the thing that is happening in the memory. What we know, that in C we should understood that how the memory is divided internally and what part of the program goes in which section of the memory. That is the one of the important thing. So the thing is that what we should know, that if we run a C program, that will create object file, and there are some, you can say, the library file. And what do you mean by object file? That means there are some, say, source files, there are some, you can say, user defined header file, user defined header files, and we are compiling the program. That means we are compiling the program, and that will create object file. And you know, there are some standard, you can say, header file, there are some standard header file, and again this standard header file, that means some library that will also compile. And then there is a linker, there is a, you can say, linking, and after linking that will produce the executable code, that will produce the executable code. That is the thing that we already know. So now, so what do you mean by user defined file? That means user can also define some file and some header file, that means some standard header file, that means printf, scanf, all those things are happening there. So what we know, after compiling and linking, the binary executable of program that gets generated, like that in windows.exe file is generated. And when this executable binary is actually executing, that means it is called a process. What I am saying, that means that will produce .exe file. So what I am saying, when, you can say, when this executable, when this executable binary is actually executing, actually you can say executing or running, then you can say it is called a process. It is called a process. That means process means, that means when it is executed, program that can store in some memory. So when a process is executed, then what will happen? When a process, when a process that is executed, first it is loaded into memory. First it is loaded into memory. Memory means the RAM, that is called random access memory. An area of the memory where the process is loaded is called process address space. That means the area of memory, area of memory where, you can say, that process that is loaded is, you can say, called process address space. This is called process address space. That means the first thing that you have to clear, that program, that does not mean that it is always executing. Program can store anywhere. Now when you are double clicking on the executable file, then it will be running, and that is called a process. And when a process is executed, that should be loaded in RAM, otherwise how can be it executed? So there are some area of memory where the process is loaded, and that is called process address space. So you can say that there are RAM, and when you write a code, there are several sections in the RAM. This is the RAM, you can say this is the RAM, but RAM itself has different memory. The first memory, you can say this is the code segment, this one is the data segment, and you can say that one is the heap segment, and that one is the stack segment, and that are something which is called unmapped. That means that is not mapping. And heap segment, that would be moving downward, and the stack segment, that is moving upward. That means in the code section, all the executable code, all the, you can say, executable code that has been stored in the code section. In data sections, if you write something like a global variable, or you can say static variable, this static particular data, that would be stored in a data section. That is the section of the RAM. RAM itself divided into these 4 sections, that is code section, data section, heap section, and stack section. The executable code that will be running in the code section, the global or the static data that will be running in the data section, and the thing that is our today's discussions, that means dynamic, you can say, memory, dynamic memory. That means when you allocate it, you can say using malloc, this is a particular function, we will discuss it, calloc, you can say, or new, etc., then that would be called dynamic memory. And when you just assign the memory by using this malloc or calloc or new, that would be stored in the heap section. And in stack sections, all, you can say, the activation records of the function. That means when you call some functions, activations record of, or when you use some recursion mechanism, that would be stored in the stack. And unmapped means, we will see in the last chapter that there are some command line argument. There are some command line arguments, and we will see that there are some environment variables that has been stored in that particular section. That means when you write a program, it doesn't mean that all the things that would be stored in a just RAM. RAM is itself divided into 4 sections. One is the code section, one is the data section, one is the heap section, and another one is the stack section. But my today's concern is on the particularly, that is the heap section. And heap memory, you just see that code sections, the memory is very less, whereas the data sections, the memory is something bigger than that, and the heap section, you can say, that would be the biggest memory, and the stack section is also. So that's why if we want to run a program, if we can allocate the memory from heap, it will be beneficial for us. So the thing is that when we discuss about the code section, what are the code sections? Because that are the important thing that you have to know. This is called, you can say, code segment. So code segment e ki thake? What are the things that code segment actually contains? This segment, that particular code segment, that means this particular, you can say, segment that contains, you can say, machine code, that contains machine code. That means in the form of executable instruction, machine code of the, you can say, compiled program, compiled program. Second one, you can say it is a read only and cannot be changed when the program is executing. That means that's why that is a fixed memory. That means this is the read only. This is the read only memory, and this, you can say, cannot be changed. This cannot be changed when the program is executing. When the, you can say, program is executing. That is the second point that you have to remember. And size of the code section, that means you have to ensure the size of the code segment that is fixed, you can say, at load time. You should remember that should fix at load time. That is the three things. That means we will see by example what is the meaning of that, but still you should just remember that are the 3 points that you have to remember. Another one that is called, you can say, data segment. What is data segment? That means all global and static data variable, and you can say static data variables are allocated, or you can say allocated memory in this segment, memory in this particular segment. Now you may ask the question, if you don't know about the static and global, it may be possible you don't know about the static and global. That are the, you can say, the storage class. This is, I am deviating from that. The storage class, actually the storage class has four. One is called auto, one is called, you can say, the static, one is called global or extern, that is called extern, and another is called, that one is called like that, the registers. So the thing is, these four are the storage classes. I am not discussing in details, but that is one of the important thing. I just want to say what do you mean by this and what do you mean by global. Like that, when you have to write the program, say has include, you can say, stdio.h. You just write the program like that, has include stdio.h, and you just write integer a equals to 5, and then say integer main, and all those stuffs are there. So when you write this variable before main, that means that particular variable can be accessed by all the functions, whatever you can write in the program. That variable a can be accessed by all the functions or all the main functions. That is called the global. That means this is global. That means you should write outside the main functions. Now there is a very interesting difference between the static and, you can say, static and, say, auto. What is the basic difference? I am just giving one example, and I am sure that you understood the concept of static and, auto. That means whenever you write, you are not writing anything, that is nothing but an auto. That means, say I am not writing the whole program, but you just remember, say this is a main and there are some function. I am calling this function, say increment, say increment, say increment, and I am writing like that, say increment, you can say, and I am writing integer I equals to 1. When you write anything, most of the program you are not writing like, you are writing this. That means that is nothing but a auto. This is nothing but a auto, and I am just want to print %d, and you can say the value of I would be increased I plus 1, and I am writing the same program. I am writing the same program, say this one is a increment, and the second one that is increment, and the third one that is also you can saw increment, and I am writing like that. Increment is nothing but you can say I am declare is a static, this one is a static integer I equals to 1, printf you can say %di, and here I equals to I plus 1. So what do you think that what should be the output of this? That means if you write like that, what would you think that what should be the output of this? That means in that particular case, what should be the output of this? So what we will find in the first case, in that particular case, what will happen? I am calling this increment, that means that goes to there, the value of I equals to 1, you are printing the value of I, that means 1 is printed, and you are incrementing the value equals to 2. But again that control will be back to the this increment, and again you are calling the same functions, right. So when you are calling the same function, you just forget the value that has been incremented, that means it again print 1. And again you are calling this increment, that means again that will print 1. But if we write this with the static variable, that means every time that will print 1 and then 2 and then 3. That is the main thing, that is the corresponding thing. So that is the basic difference. If you talk about the difference, that is the basic difference between auto and static. Auto means if you are not writing anything, that is auto. So that's why what the point that we actually mentions, that means data segment, that means all global and the static data variables, all global and the static data variables that are allocated memory in this particular segment. In this particular segment you are allocating. We will see an example, then you can understood what is the difference like that. The second point that you have to understood about the data segment, that is memory is allocated in this area, that means memory that is allocated, you can say in this area when the you can say program is loading, when the program is loading, that means before the main function called load times variable, that means এটা কি হয় মেমোরিটা allocated হয়ে যায় in this area when the program is loading, মানে বিফোর দ্য মেন ফাংশন কল করার আগেই যা যা যেমন ইন্টিজার আমরা স্ট্যাটিক হিসেবে কি করি, we are just defining the variable and all those stuffs and the memory is already been allocated, you cannot change the memory, right. So that's why you can say that particular, that means this global and static, this global and static variables are also called, this is called load time variables, that are also called load time variables, right. So these are also called load time variables. What are the reason behind that? Because you are allocating, you have to allocate the memory before that. Initially when you are declaring global like that, if you want to like that, if you want to write say static integer a, and I just want to print the value, that means printf %d, I want to print the value a. You just imagine I am not initializing anything, but I want to print the value of a. If we declare it as a static, automatically the value of a is 0. Automatically you can say the value of a that is equals to 0. That is the thing. So if that will happen, you can say when you are declaring static integer a, but if we just like integer a, if you are not writing anything, that means you are writing auto, and again if you any printf %d and a, that will give you the garbage value. Garbage value, that means I don't know about the value. It is unpredictable, right? So, and that's why this global also, that will be happen for the global. That means the initial value of the global, that is nothing but, you can say initial value is 0. So, if in some questions, in some interview, if someone asks you that there is an 1000 room array, there is an, you can say 1000 room array dot 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 dot, there is a 1000 room array, and you have to initialize, this 1000 room array with zeros. Then you can write simple. That means if you write static integer, say the name is array and 1000, then automatically the 1000 rooms array is initialized with 0, and that's why the initial value, you can say the initial value of this is nothing but, you can say that is nothing but 0, right, for the global and the static. So, what we can say from that particular memory, what we can understood from that, that all load time variables mean this global and static, that means all, you can say load time variables, all load time variables, that means this global and static, are initialized, at the load time, at the, you can say load time, that would be initialized. If no initial value is given, if no, you can say initial value that is given for a load time, variable, then it is initialized, then it is, you can say initialized with the 0 of its time. তার মানে if it is not, you can say automatically that would be initialized with 0. That means the size of the data segment, that is fixed at load time and does not change when the program is executing, right. That means you can say that the size of data segments, that is, you can say fixed at load time, and that does not change when program is executing, that is the one of the important thing. So, this is nothing but the data segment. Now, we will understood the thing that is called the stack segment. You already know about the stack segment. This is nothing but the stack memory, right. So, that means you can say in that particular case the stack segment, that you can say contains activation, records, of all the active function. আমরা কি জানি, যখনই কোন একটা ফাংশন কে কল করা হয়, we will store the thing in the stack memory, that is called active function. That means an active function মানে কি, an active function, you can say, is a function that is, you can say, currently under the call, that is the main thing. So, what we know, when a function is called, what will happen, its activation record is created and that would be pushed into the stack. What we understood, that anything that would be pushed in the stack, like that. Whenever you call the functions, that would be put into the stack, and when it will be returned, then it will be popped from the stack. That means you just know that when a function that is called its activation record is activation records, you can say that is created and pushed, on the top of the stack. That means whenever you call a function, that would be stored in the stack segment, that are the 3 segment, and the last one, that is the heap segment. But before going to the last section, I just want to run a simple program. And just by seeing the program, just predict the output. Say, so this is a simple, I am just writing the program, say integer main, I am writing like that, say static, you can say integer I equals to 5, say, and if minus, you can say minus I just want to call the main again, I am called the main again, right? I am calling the main, and printf, you can say that %d, printf, say %d, and I just want to print the value of I. That is just a simple program. What I am declaring? Static integer I equals to 5 if minus I, then I am calling the main function again, and I just want to print the value of I. Then what should be the output, right? Because you know I equals to 5, you are decrementing the value of I, you are calling the main function again, you are printing the value, right? So if you think normally, then it may be like that, the first 5 4 or 4 3 2 1 0, that should be printed. If you think like that, if you run this particular thing, if I am running this particular program, let's see whether it will run or not. You just see the output, that will give you 4 zeros, that will not give you 5 or 4 3 2 1 0 like that. What they will give you, that will give you 4 zeros, and that is the one of the interesting thing that you have to think of. So in that particular case, what will happen? In that particular, you can say, in that particular case, what we can say, that the output is giving as a 0 0 0 0. Now the question is why? And this is due to this memory segment. This is due to the memory segment. Why? Because you are writing the program. That is a program that I am written here. That is the corresponding program. What is the program? The program is that I am declaring static integer I equals to 5. Now you know about the memory. This is, you can say, that particular section, that is nothing but the stack section. And you know, when you have to declare it as a static, there is a data section in the RAM. So the variable would be created like that. This one is a 5, right? Now what will happen? I am writing like that integer main, and I am again calling the main, and of course the condition is given like that. You can say if minus minus I, excuse me. So this is a percent %d and I, you are calling the main. So what we know? That means first this main function has been called. So main would be pushed in the stack. You know about the recursion. I am just giving the number like that. So within integer main, what I am written here, the static integer main is written here. This is not written. This is static integer I equals to 5, and then I am if condition. That means this is line number 1, this is a line number 2, this is a line number 3, this is a line number 4. Now you are calling main function. When it is within this is a minus minus I, that means this would be 4, and you are calling again main. So you are calling again main. So that means when this main has been called, it will be returned to the line number 4, because that main has been pushed into the stack, and then again the main has been called, an integer I equals to 5, then I minus minus, that means that would be, you can say that would be 3, and you can say that would be 3, and again main has been called. That means again you have to back to the line number 4, because main is called like that. Value of I is 3, again that value is 2, you are calling the main, again that would be back to the line number 4. I am just writing there, that would be decremented 1, and you can say that would be, this is a main, that would be back to the line number 4, and then it becomes 0. When this becomes 0, that means this condition fails. That means this main will be popped out, and that will execute line number 4, and line number 4 that will print the value of I, but the value of I that is already been 0 here. So what will happen? When you are just printing the line number 4, it will print 0, because I is now 0, and again that will be popped. You are printing line number 4, that means you are printing the value of 0. You are printing again the value of I, that is also 0. Again you are printing the line number 4, that is 0. So that's why in that particular case that will print, you can say 0 0 0 0. If you not understood the thing, you just go through the video, then you will understand. The main problem is that when you have to declare static int I equals to 5, that would be allocated in the separate memory, and when you call the main function several times, that would be allocating in the separate memory. So that's why when you are decrementing the value of I, that would be decremented in a separate memory. Now when you want to print the value of I, that is already been become 0, and that's why it will print I 0 4 times. And that type of program is important. You will face this program in interview, you will face this program in GATE, but you just remember the thing that when you are declaring a variable as a static, that means it should create in a different memory locations, and that's why that will happening. That's why that is happening. So that is one of the example that I want to mention. Now the thing is that the only sections that is left, that is nothing but the heap section. That is nothing but heap section. So if we take an example, so the thing is that what I am discussing about the dynamic memory allocation, and when we are discussing about the dynamic memory allocation, there is one thing that is called nothing but the heap sections, right? This is nothing but the heap section. And you know, whenever you heap section, or you can say segment, whatever be the thing, whenever you are allocating memory by using dynamic memory allocations, that is always done from the heap section. That means when, and you cannot just allocating the memory from the heap, you have to use a particular function that is already been written in some library file. Like when you use pow functions, you have to include mat.h, like that. when you have to use dynamic memory allocations, that means you have to use some predefined functions. That means when we allocate, and that is the common questions in your semester examinations also, that what are the difference between the malloc and calloc. That is a specifically that type of questions that are coming in your all the semester examinations. So you just play the concentrations. So when we allocate memory at runtime using malloc or calloc, malloc, calloc and realloc. There are three functions. Realloc in C language. In C language, if we are use dynamic memory allocations, then we should use these three functions. And there are some new that type in C++. C++ এ আমরা new আর new দিয়ে একই কাজটাই করি, সেখানেও এই চারটে জিনিস ভ্যালিড, মানে malloc, calloc, realloc C++ এও আমরা ইউজ করতে পারি। Then if we allocate memory at runtime by using this particular function, then that memory is allocated, on the heap, and it is called dynamic. It is called dynamic memory. It is called dynamic memory or runtime memory, or you can say runtime memory. So in C language, we cannot initialize the memory allocated on heap, and memory allocated in heap does not have a name, right? The only way to access this memory is via pointer. তার মানে হিপ সেকশনে, র্যামের হিপ সেকশনে যদি কিছু তুমি অ্যাক্সেস করতে চাও, নর্মাল ভাবে তুমি করতে পারবে না without the using of pointer. Pointer ছাড়া you cannot do anything within the heap section. That means the only way, you can say way to access this memory is via pointers, you can say pointing to it. And if we lose address of this memory, there is no way to access it, and such a memory will become memory leak. এই কোশ্চেনটা ইন্টারভিউতে প্রচুর জিজ্ঞেস করে। or what do you mean by memory leak? কি বলবে, when we have to access the heap section, then we have to use the pointer, but if we lose the address of pointer, then what will happen? Then that particular memory is not traceable, and that will become called a memory leak. And mind that it is one of the largest source of error in C or C++. Mind that one, because in Java there is an automatic garbage collection, but in C or C++ that is the responsibility of the programmers, right? So if we write a simple, so what we understood from that, that heap is a very large memory, and that is free during the entire program execution. The compiler cannot refer to this memory during compilation, মানে তুমি যখন compile বাটনটা টেপো তখন কিন্তু heap section কে ইউজ করা যায় না, যখন তুমি ওই যে কালো স্ক্রিনটা এলো, কালো স্ক্রিনটা এলে ইউ আর জাস্ট এন্টারিং দ্য ডেটা অ্যাট দ্যাট টাইম, যখন তুমি মেমোরিকে অ্যালোকেট করো তখন তাকে রান টাইম মেমোরি বলা হয়। দ্যাট মিনস দ্য প্রোগ্রামার শুড ফাইন্ড এ ওয়ে টু রেফার টু দিস মেমোরি। হিপ ক্যান বি রেফার্ড অনলি অ্যাট রান টাইম, and that's why this is called a dynamic or runtime. Dynamic means runtime, and the heap can be allocated to variables, strings, arrays only through pointers at during the runtime. And when you have to use the heap memory, you should use that particular functions, inbuilt library function that are malloc, calloc and realloc. And when you have to free that, you have to use this free variable. That means if we write a simple program, say I am writing integer, say variable 1, say you can write like a float, that is a variable 2 equals to say 10.25. Say I am writing a functions, that is an arbitrary program, this is an arbitrary program. I am writing integer star ptr, say integer x equals to 100. That means you can say star ptr is equals to say malloc x and then free ptr. Excuse me. That is a void main, and within the void main I am writing integer x equals to 10 and say integer y. I can write like that static integer p equals to 20 and say I am calling this particular function. Then what will happen? When I am declaring any variable, but this variable is uninitialized, so that would be stored in the data section, and data section also two part. I am not going details, but data section itself has two part. One part that will store the uninitialized variables, and that would be also stored in the data section, but in the part of initialized segment, right. This is a void start ptr, that means you can say that is a pointer, but this pointer is written within the function, that means that will be allocated on, you can say, stack when the function is called, that is called. And just I am initializing this thing, that means that would be in data segment, and this is a malloc, right. That means when you have to write this particular malloc, that means that would be allocated in the heap, and also free means deallocated from the heap, that means that part would be stored in the heap section. And within main you are written this, because when you are calling this, that would be also stored in the corresponding stack. When you are declaring static, that means that would be stored in the data segment. So whenever you write a program, that all are, you can say, that all are running in the RAM, but the different portions of the RAM, because RAM itself can be divided into different sections, right. So if we just try to differentiate between the static, and you can say dynamic memory, you just understood that when I just create a variable or array in the program, the memory is allocated by the compiler either on data segment or stack segment. That means the C compiler that will allot memory during the compilation timing. That means that before the execution of the program, and allocating memory in this way during the compilation time, that is called the static memory. What I am saying, you are nowadays, now in every program till now, you are just written some integer like that you are just written integer a, or you write a array like that a10, and this all are the memory that has been created by the compiler during the compilation time. That are the not the memory which is created at the runtime. That means that will be created before, you can say, the execution of the program. That means when you have to write like that, what will happen? The C compiler that allots memory, when, you can say, during the compilation time, during the, you can say, compilation time. That means before the, you can say, execution, before the execution of the program, before the execution of the program. And what I am saying, that allocating this memory, allocating memory, you can say, in this way during the compilation time, during the compilation time is called, you can say, static or compile, static or compile time memory. This is a compile time memory. So that means what I am saying, that that memory, you can say that there is a huge amount of memory that is called the heap section, but that we cannot use that. If we want to access that huge amount of memory, we should use the variables, you should use the variable. So you can say, whenever you declare anything by using malloc, calloc, or you can say realloc, the memory should be created in the heap. What will happen? This is the heap, this is the heap. Say in that particular heap there is a variable, and each variable has some address, and that address should be accessed by the pointer, and pointer set 1005, that means that is pointing to this, but this pointer is stored in the stack section, but the memory that has been allocated by using malloc and calloc, that would be stored in heap section. That is the thing that we want to say. Now if we talk about the malloc, or if we talk about the calloc, then this particular malloc function, how we can write? That means by using malloc, how we can write anything. That means before you can use the malloc, you have to use some ptr, right? And ptr, that should be equals to integer star, I am typecasting with that, and if we write like that malloc, say in star, you can say size of int, that means at the runtime the user will give the value of n, and depending on the value of n, the memory has been created, the memory has been created. So by using malloc you can create like that, but I think you will not understood the concept. So if you want to understood the concept, I am going through a simple program, then I think you will understood both the concept, how we can use the dynamic memory allocation. Like এটা ভালো করে বোঝো, তাহলে এই ব্যাপারটা ক্লিয়ার হবে। ধরো what I want to implement, I want to implement linear search। আগে linear search কি জিনিসটা বোঝো, then I try to implement that। linear search, linear search means কি? linear search মানে user কি করবে? user will give some values, user will give some values, and what will happen? That would be stored in an array, and the thing is that then user give another value, user give another value which they want to search, say the value is item, and then what will happen, say ধরো user দিয়েছে এরকম say 10 20 50 5 2 এরকম কিছু ভ্যালু অ্যারেতে, this one is an array. Now user want to search for an item, say user want to search whether this 5 element is there or not, like that আমরা যেমন বুক সার্চ করি, বুকে কি থাকে, ইন্ডেক্স থাকে, সেই ইন্ডেক্স দিয়ে আমরা কি করি, সার্চ করার চেষ্টা করি, কি সার্চ করার চেষ্টা করি, যে কোন এই ভ্যালুটা আমার বইতে পাওয়া যাবে কিনা, যেমন ইন্ডেক্সে আমরা দেখি, রাইট। সো দ্য থিং ইজ দ্যাট যেটা ভয়েসে দেখি মানে আমরা দেখি সাধারণত সেটাই আমরা দেখি। তার মানে কি করবে, যখন এই 5টা দেবে তুমি প্রথমে 10-এর সাথে সার্চ করবে, পেলে না, 20-এর সাথে সার্চ পেলে না, 50-এর সাথে সার্চ করলে পেলে না, 5-এর সাথে ফেলে, তাহলে ও কি করবে, এই পার্টিকুলার ইন্ডেক্সটাকে রিটার্ন করে বলে দেবে হ্যাঁ আমি এলিমেন্টটা পেয়েছি। এটাই তো লিনিয়ার সার্চ, সিম্পল। তাহলে দেখো লিনিয়ার সার্চ করতে গেলে প্রবলেমটা কি, লিনিয়ার সার্চ করতে গেলে আমার যেটা থাকে যে আমাকে প্রথমে ইন্টিজার একটা অ্যারে ডিক্লেয়ার করতে হবে, আমি তো জানি না কত ইনপুট দেবে, তাহলে আমি ধরে নিলাম ম্যাক্সিমাম 50 খানা ইনপুট নিতে পারে। তাহলে এই দেখো এই যে প্রথমেই একটা আমরা কি করি, একটা নর্মাল হ্যাশ ইনক্লুড দিলাম stdio.h, দেন আমি কি করলাম ইন্টিজার মেন দিলাম এবং এখানে ইন্টিজার a ইকুয়ালস টু 50 নিলাম। হোয়াট ডাজ ইট মিন, তার মানে আমি কিন্তু একটা অ্যারে তৈরি করে দিলাম অলরেডি, যার সাইজটা 0 1 থেকে শুরু করে 50। বাট দেখা গেল যখন প্রিন্টএফ এ তুমি কি বলো, প্রিন্টএফ দিয়ে তুমি বলো এন্টার নাম্বার অফ, ইউ ক্যান সে এন্টার নাম্বার অফ ডেটা, অ্যান্ড দেন তুমি কি করো একটা scanf দিয়ে ইউ আর এন্টারিং দ্য ডেটা অ্যান্ড ইউ আর স্টোরিং দ্য ডেটা ইন n। তার মানে ইউজার হয়তো দেখা গেল n এর ভ্যালু 5 দিল, তার মানে দেখা গেল তুমি 50টা রুমের একটা অ্যারে ইনিশিয়ালাইজ করেছো, অথচ তুমি কি চাইছো 5টার মাত্র ডেটা দিয়েছো, তার মানে বাকি যে ঘরগুলো পড়ে থাকলো সেগুলো তো ওয়েস্টেজ অফ মেমোরি, রাইট। তাহলে এটা হচ্ছে স্ট্যাটিক মেমোরি, মানে তুমি কম্পাইল টাইমেই এই মেমোরিটা অ্যালোকেট করে দিয়েছো, তার মানে এটাকে আর কিন্তু তুমি চেঞ্জ করতে পারবে না, এবং দ্যাট উইল ক্রিয়েট এ প্রবলেম। এখানে ডাইনামিক অ্যালোকেশন, কারণ দেখো র্যামের সেকশনের ইউজ করছো, তুমি যখন একটা প্রোগ্রামকে রান করাও তখন কোথায় রান করো, র্যাম, তোমার র্যামের সাইজ 4 GB 8 GB 16 GB। র্যামে তো শুধু এই প্রোগ্রাম রান করছে না, তুমি মুভি দেখছো, এই যে আমি ভিডিও দেখছো, তুমি হচ্ছে অপারেটিং সিস্টেম রান করছে, whatever you did in your computer that is already been run। তুমি যদি টাস্ক ম্যানেজার ওই কন্ট্রোল অল্ট ডিলিট টিপে যদি টাস্ক ম্যানেজার দিয়ে অ্যাপ্লিকেশনস গুলো দেখো, তাহলে দেখতে পাবে প্রায় 100টা অ্যাপ্লিকেশন অটোমেটিক্যালি ভেতরে রান করছে। তার মানে অলরেডি অপারেটিং সিস্টেম তোমার র্যামের একটা অনেক জায়গা নিয়ে বসে আছে, তারপরে তুমি মুভি দেখো কি গান শোনো কি whatever you did everything is running on RAM। তাই জন্য আমার র্যামকে যতটা কম ইউটিলাইজ করতে পারবে, যতটা স্পেসিফিক্যালি ইউজ করতে পারবে, তত বেটার আমাদের অ্যালগোরিদমিক কমপ্লেক্সিটি হওয়ার কথা ইন রেসপেক্ট অফ টাইম। র্যামে আমার কম জায়গা খাচ্ছি স্পেসের রেসপেক্টেও, এবং তাই জন্য ডাইনামিক মেমোরি লোকেশন আমরা ইউজ করি। তাহলে এখানে দেখো ডাইনামিক মেমোরি মানে আমাকে যদি নর্মাল প্রোগ্রাম লিখতে হতো, নর্মাল প্রোগ্রাম আর ডাইনামিক মেমোরি অ্যালোকেশন দিয়ে করার মধ্যে খুব একটা তফাৎ নেই। তোমাকে কি করতে, তোমাকে প্রোগ্রামটা কি লিখতে, তুমি i ইকুয়ালস টু 0 নিতে, i লেস দেন n নিতে, i প্লাস প্লাস নিতে, এবং ধরো এটা আইটেম, আইটেমের মধ্যে তুমি হয়তো নাম্বারটা, আইটেমটা আমি ধরে নিচ্ছি এম ভ্যালু, ধরো এই এম ভ্যালুর মধ্যে ইউজার দিতে চাইছে যে কোন ডেটাটাকে তুমি খুঁজে বার করতে চাও। তখন আমি কি করলাম, আমি একটা ইফ কন্ডিশন নিলাম, ai নিলাম ইকুয়ালস টু এম হলো, এবং এটা কি করবে যদি ম্যাচ করে তাহলে রিটার্ন করে দেবে i। এই তো সিম্পল একটা প্রোগ্রাম লিনিয়ার সার্চে, মানে এই একটা সিম্পল প্রোগ্রাম। বাট এখানে প্রবলেম কি, আমি আগেই ইন্টিজারে একটা অ্যারে সাইজ 50 করে রেখে বসে আছি, এবং সেটা কম্পাইল টাইমে ইউ ক্যান নট চেঞ্জ ইট, এবং সেই কারণেই আমি কি চাইছি, আমরা চাই যেটাকে ডাইনামিক মেমোরি লোকেশন অ্যালোকেশনস দিয়ে এটাকে করতে। এবং ওয়ান থিং, তোমাদের পরীক্ষায় বা তোমাদের ইন্টারভিউতে সবসময় বলে দেবে, যদি প্রোগ্রাম লিখতে দেয়, ইন্টারভিউতে গেলে প্রোগ্রাম লিখতে দেয়, সেখানে ওরা দুটো জিনিস স্পেসিফিক্যালি মেনশন করে দেয় যে তোমাকে লিনিয়ার সার্চ করতে হবে বাট বাই ইউজিং ফাংশন, লিনিয়ার সার্চ করতে হবে বাট বাই ইউজিং ফাংশন and as well as dynamic memory অ্যালোকেশন ইউজ করে। তাহলে আমি সেম প্রোগ্রামটা লিখছি, দেখো। তাহলে আশা করি লিনিয়ার সার্চ ব্যাপারটা আগে বুঝেছো এবং সেটা আমি ইমপ্লিমেন্ট করতে এই নর্মাল ভাবে পারি, বাট ডাইনামিক মেমোরি লোকেশন অ্যালোকেশন দিয়ে যদি করতে হয় তাহলে কিভাবে করবো এবং ফাংশন দিয়ে। তার মানে দেখো সিম্পল ব্যাপার, আমি এইভাবে প্রোগ্রামটা লিখতে চাইছি যে কি বললাম, আমায় hash include, you can say stdio.h কে include করতেই হবে, and as well as since we are using dynamic memory allocation function we should use stdlib.h. either there are lots of library file are there, malloc.h, calloc.h, তুমি যে কোনো কিছু ইউজ করতে পারো, but if you can use stdlib.h, that means that will already containing the all the library files of dynamic memory allocation, that means malloc, calloc, realloc and free. So I am just writing a function that will return integer. Why that will return integer? Because what I want to return the number of the position where the element has been found. And you just understood this search operation is being used everywhere. That is one of the predominant operation in our computer science, because whether you are searching for a ticket in your app, whether you are doing something in your books, you are just nothing but a searching every time. So that search should be implemented by some of the search method. So so that will return the integer, that means it will return the position, and I am just giving the name of the function is search, and I have to write this is an array base address, integer n, that is the number of elements, and this one is the integer m, that means the element that you want to search, that means that is the element that you can say want to search. This is nothing but the total number of elements, and this is nothing but array. Now what will happen? The linear search is very simple. Integer I am just writing for I equals to started from 0, I less than n and I plus plus, and by using if I am just checking whether the value of ai equals to m or not. If this will happen, it will return I. If this will not happen, it will return -1. Why? I